Hi everyone! In this video, I will show you how to create a meteor shower effect using JavaScript so you can add it to your website. First, we will design a single meteor, then use the canvas to draw it. After that, we will animate one meteor, and finally, we will turn it into a full meteor shower animation. Let me show you what each part looks like. Let's start by designing the meteor. Here is the project, and as you can see, here is a comet or a meteor. We have the code that will allow us to change how the meteor looks like. You can see that now it is a little bit bigger, just so that you can see how it looks like. I have the code, but I will show you this later. So I can change, for example, the rotation of the meteor. So I can rotate it by, as you can see, 45 degrees. I can change that to 60 degrees, whatever. I can also change the length. So let's make sure that the length is smaller. I can make it bigger. I can also control the line width. Currently, you can see that the width of the meteor is big. Now if I change the width, you can see it became smaller. This first component will allow us to design the meteor. Once we are happy with the design, we can move to the next step, which will be to animate this meteor. So let me show you how this looks like. Here is the new component. You can see that we had the same meteor. It is rotated by an angle, and I have placed it here on the top left corner. And you can see that here we have a message that says to press enter in order to move the meteor. So I will press enter, and as you can see, the meteor is moving. And here I can control the step so that I can make the meteor move faster or slower. I am doing this because just to show you how the logic happens and the math behind moving a meteor using canvas. I can keep hitting enter, and as you can see, we get the movement. So this is manual just so that we get familiarized with how to move a comet or a meteor. And in the third component, we will make this automatic so that we let JavaScript control this without us hitting any key. So let's see the third component. Okay, so here is the third component. Here we have a control panel that will allow us to change those parameters like the meteor speed, length, width, etc. So let me collapse this. As you can see here on the top, we have meteors coming automatically, so there is no need for us to click any key. JavaScript will handle this automatically. And here I have made sure that the meteors come from here, from the center of the page. And here we have these control panels this control panel that will allow us to change these parameters. I said that the meteors come here, and to control that we have this radiant position. So currently it is set to -50 pixels. I can change that to -500 if I want. And as you can see, now the angle has shrinked. We will see this effect very well if I decrease the pause minimum and pause maximum times, because these control the frequency at which we show meteors. And as you can see, now we get a lot. So let's decrease that to 100 milliseconds. And as you can see, we get a lot of meteors. You can see that the angle is big. So if I keep decreasing the radiant position, you see now that angle has been shrinked. We can control the line width. So you can see that now we are getting some meteors that are big, some are very small, because here we have two values. We have line width max and line width minimum. Let's put everyone at 1 pixel, and as you can see, all of them now are small. We can control the speed. Let's give some a higher speed, and let's have some slow comets or meteors. And as you can see, some move very, very fast. We can control the length. Let's have some meteors with big lengths, and some of them should have lower lengths. So you can see that these parameters will allow us to change the parameters automatically in the UI instead of going to the code and hitting save each time. And it gives us a direct feedback so that we can save these parameters and put them in the code and then hit save so that we use this later. Okay, and if you are happy with this, you can close the control panel and look at the design. Okay, so these are the things that we are going to build in this video. We are going to dive deeper into how this works. We are going to use a lot of math. So I hope you will enjoy this tutorial. Now let's see how to design the meteor. You can design it in different ways, but here is what I propose. We will start with the tail. We will draw it like a triangle, and after that we will add to it the head. This will give us the comet. It will look like this. We are going to use the canvas in HTML to draw the meteor. And here are the steps that we will follow. So this is the canvas. We are going to find the center point, and then we will have 2 points. So this one is going to be for the head and this one for the tail end. And then based on these 2 points, we will be able to draw the tail. And finally, we will add the head in order to finalize the comet design. You will keep hearing me say comet, meteor, so I will use these two terms interchangeably, but I mean the same thing. You can see that I am putting the meteor in the center of the canvas. You might say, why are you doing this? Just to make things simple in the beginning, but after that we will add rotation, we will put the comet anywhere in the canvas, so don't worry about this. We will keep things simple in the beginning, but we will add more complexity after each step. Let's start with the first step, which consists of finding the center of the canvas. Here is the code associated with this step. You can see that we have the draw commit method, and let's go through the code inside it. So the first line of code will clear the canvas. So we will start with a canvas that doesn't have anything. After that, we will use the width and height of the canvas in order to find the coordinates of the center point. So you can see that we take the width and height and divide them by 2. And after that, we use this code in order to draw the point here. I am using this just for debugging, but later I will remove it. I always do this so that I can see what I am doing. So begin path will start drawing the path, and here arc will basically allow us to draw a circle. The arc method takes the coordinates of the point. Here in this case the radius is 8, and finally we need to provide 2 angles, the start angle and the end angle. If you provide 0 to 2 pi, this will draw a full circle. But if you provide 0 and let's say pi, that will draw an arc. Okay, so as I said, I use this just for debugging, but later I remove this code. Now let's see how to locate the head and the tail end of the tail. Here is the code. You can see that now we have more lines of code, but let's go through it step by step. We already have the center point. Now I am using this scale variable in order to be able to increase the size or decrease the size of the meteor. So here we already have the length. So here we will see this in VS Code. So we have this object that contains the length property. So here we will multiply that by scale in order to get the new value. And based on this, we will take the center coordinates and add the scale length divided by 2. So this will give us the head point. And again, we will use the same code in order to draw it in the canvas. Similarly, we will use the same technique, but here we will decrease, or we will subtract the scale length divided by 2. And finally, we will draw that point here. Okay, so now we have the coordinates for the head point and the tail point. Now we are almost ready to draw the triangle. We just need to have those 2 points for the base of the triangle. Okay, so this is what we want. So we already have these 3 points. Now we need to get the missing 2. But how do we do that? Let me show you. First, I am creating this gradient. You can see that here we have a gradient that goes from white to black. So let's create it. So here we have this method, create linear gradient. You need to give it the coordinates for the first point and the second point. Here I took the head as the first point, and 0 refers to the head, and 1 refers to the tail. The first color stop will be a white color with an opacity set to 60%. And in the second color stop, we will use again white, but this time we will set the opacity to 0%. This will basically give us the color black, or it will give us a transparent color. So this gradient will go from a white color to a transparent color. And here is the direction of that gradient. So if you want to reverse the direction, swap these colors. So you can have, for example, here 60% and in the first color stop 0%. Okay, let's continue. Now we have this perpendicular point. So here we have the x coordinate and the y coordinate. And again, this one is going to be used for rotation. Currently, the angle is set to 0. So the sine of 0 is basically 0, and cosine of 0 will give us 1. But if we decide to change the angle, this will help us draw those points correctly when the comet is rotated. But for now, the angle is 0, so it doesn't matter. Okay, so let's see how this will help us. So head base 1 will be the point that will be below the middle point. So how are we doing this? So let's go coordinate by coordinate. Let's start with x. So we take the head x, which is here, and we add to it the width, because you know the width is the base of the triangle. So we need to add just the half of it. And we multiply that with perpendicular x. So perpendicular x is equal to 0. So this means that the x will stay the same. But if we go to y, so we take the head y, which is in this case is in this position, and we add to it the width. And here perpendicular y is equal to 1. So we will be able to add that width, and this will push the point to below, because in the canvas the origin is 0, 0, and it is here in the top left corner. So by adding, we will go down, and if we want to go up, we need to subtract the value, and this is what we do in the second case. So for head base 2, again, perpendicular x is 0, so we will use the same head x, but for y, we will subtract the half of the width. Okay, so this will allow us to add those missing points. Now, how do we draw the contour? So here we use the same method, begin path, and we have this handy method that will move let's say the pen to this point. So I am starting at head base 1. I will draw a line between it and head base 2. And after that, I will go to the tail point. Now everything is set. I can use the close path to close it. And finally, we use that gradient as the fill color, and we call the fill method to basically fill the contour. And this gives us this result. Okay, so finally we can add the head to complete the meteor. So let's see how we do this. Again, we use begin path. We already have the coordinates for the head point. We use the arc method. We have talked about this before. So the point will be the head. We have the radius, which should be the half of the width, and we have 0 to 2 pi in order to draw a full circle. And we use white. As the fill color. Now let's see the final result. This is what I will show you in the code. But if we set the width to 10, it gives us so here the width is 10 and the length is I didn't specify the value, but you can see that the length is big. And here is the result if we increase the width. So you can see that the meteor became very large. Okay, so now I think we have everything we need. So let's open VS Code in order to show you the components that I have created for you. Here is the code inside the VS Code. And you can see that here I'm splitting the screen so that you can see the preview in real time. Here I am using Vue.js, but feel free to use any other framework, or you can also use JavaScript directly, because this is just a JavaScript code. And I am using Vue.js because it will allow me to create components so that we can create the animation very easily. But as I said, you can extract the code because here we have just JavaScript, and put that in a JavaScript file, and that will work. So here is the component. It's called Meteor Designer. And you can see that here we have, okay, let me reset the angle, because as I told you, we will start without an angle. Okay, so this is how it should be. We have this Meteor object. It contains certain fields like the length. Let's set it to 100. Okay, so that that shrinks the size of the meteor. We can also set the width. Let's set it to 1 pixel or 10. We also have the scale. This will allow us to scale the meteor. Let's set it to 10 or 1. Okay, so yeah, these are the values that we have inside this component. We also have the width and height, which are basically the width and height of the viewport. We are going to use these for the canvas. And we also have the context. This will allow us to use the methods like clear rect, begin path, arc, etc. So in this setup canvas method, we basically get the canvas from the template, get the context, and set the width and height of the canvas to be similar or to be the same as the width and height of the page. Okay, so this is the only setup that we need to do for the canvas. And the draw meteor method is called only once when we open the app, and it does the same things that I have showed you in the slides. So in the beginning, we clear the canvas. Okay, so let me show you, because this is very important. So I'll comment all this code like this, and I will use what I have showed you in the slides to draw the points for debugging. We have cleared the canvas, there is nothing. Now we can compute the center points. So we will take the width and height of the page, divide them by 2. That will give us the coordinates for the center point. And now let me just call this dot context dot begin path. Okay, and let's draw the point. You can see that here it is. Here, though, this is the radius of the point. It's big, but let's replace it by 20. And here I want to set it to yellow, maybe. But again, I am using this just for debugging so that you can understand the steps. After that, I am going to scale the length by using the scale variable. And here, now I can get the head and tail. So let me use the same code in order to draw the point for the head. So here I can change that to head X, head Y, and let's use a blue color. Okay, so here I can comment this because I am not using it. And as you can see, we have the head point here. Let's do the same thing for the tail. Let's copy this. Let's paste it here, and let's make sure to change head to tail. And here is our point. You can see that I have added something to these two lines of code. Okay, so here we have center X plus scale length divided by 2. And we have math.cos, so we use the angle. I have added this in order to account for the angle of the meteor. If I don't add this, I will not be able to rotate it. So let me show you. So currently the angle is set to 2 pi. It's similar to 0, so 0, 2 pi, 4 pi, all of those will make the comet be horizontal. So let's set it to 45 degrees. So let's divide it by 4. You can see that the points have turned. Why? Because I have added these two functions, math.cos and math.sin. And you can experiment with these. For example, if you put math.sin here, maybe you will not get the result that you want. So just by changing these values, you will get which one works in this case. Okay, so here we need to add these to account for the rotation. And make sure to do that for the head and tail. Awesome. So let's keep it like this. And now we need, okay, so here is the gradient. So the gradient will go from the head to the tail. And here we use the white color with an opacity set to 60%. And when we go to the tail, we will have a transparent color. Now we do the same thing. So we have this perpendicular point. Basically, with this point, we will be able to add those the points for the base of the triangle. Okay, so let me uncomment this. And again, let's copy this and let's paste them here. Let's use head base 1x, 1y, and here let's use maybe orange. Let's do the same thing for the other point. So here it should be head 2, nice. Let's remove this, and also let's uncomment the scaled line width because now we need it. Let's save this, and voila, you can see that we have those 2 points. Okay, what will happen if I remove this? So let's just keep it and replace angle with 0. That will mean that we don't have any angle. So you can see that we don't get the result that we want. So we need to multiply these values with the math cos and math sine. So that's just a little bit of trigonometry so that we can rotate the comet. Okay, so that works. And now we can add, we can create the contour. So before closing it, let's just keep these and just to show you what happens. So here we begin the path, we move to this point, we draw a line here with line 2, and from here we draw another line to this point and we close the path, and then we give it a fill color, which is going to be the gradient, and we call the fill method to actually draw that color. And as you can see, it is transparent because we can see the points. But if I go up and change this to 1, it will be a solid color. You can see that now we cannot see this blue point. But still here we have a transparent color. If you want, you can keep it as 1. You can play with these values and change these to 0. That will give you a black color. And as you can see now, it is completely solid because we cannot see the middle point and we can see the tail clearly. So it's up to you. If you want to use a solid color, keep the opacity set to 100%. If you want to have a little bit of transparency, play with that value. Finally, we will add the head. Because we already have the head coordinates, it's going to be easy. So we will just provide the necessary values for the arc method, and that will draw us the circle. Okay, so why I have created this Meteor designer component, basically so that you can experiment. You can see the comet in front of you. Let's say that you don't want this circle. You just like the comet to be like this, just a triangle. You can keep it like this. Or maybe you want it to be a rectangle. You can do that also. So this is, if you want to play with different designs, just go inside the draw meteor method and play with this code, change it however you like, so that you get something that works best for you. The other methods, for example, the handle resize is used to resize the canvas when the page resizes. You can see that here it resizes correctly. And mounted, before I mount, these are some things specific to Vue. And finally, we have some CSS to make sure that the canvas spans the whole page. So here we use a fixed position. We put the top left corner here, and we stretch it to fill the whole viewport. And here is the background color. Awesome. So that's it for the Meteor designer. And now in the next step, we'll see how to animate it. Now let's see how to move the comet. Here is the workflow that we are going to follow. First, we are going to spawn a comet. And after that, we are going to move it in steps. For example, in the first step, we have the comet that was spawned in this region. After that, we are going to move it by, let's say, a step at a certain direction. After that, it's going to come to this place, and finally it will be no longer visible. So this is what we are going to do, and here is an example. So here is a video that I have recorded, and as you can see, I have made sure to slow the video so that we can see the comet moving. And here is the code that we will use in order to move the comet. In the mounted lifecycle hook, so this is a Vue specific thing. Basically here, whenever we first open the application, we are going to set up the canvas. We have seen this, and we are going to draw the comet, for example, here in this region. But we are going to also add the ability to move the comet just by pressing on the Enter key. Okay, so here inside the mounted hook, you can see that we are adding an event listener. So here that event is key down. Whenever I press down on a key on the keyboard. So that is mapped to this function. So whenever I press on something, this function will be called. So the handle key press will basically check if I have pressed on the Enter key. If that is the case, I'm going to call the step animation function. And this one will move basically the comet by a certain step size. So here we are doing that for X and Y in order to move the comet in both directions. And after that, we are going to call the draw comet method again so that we remove it and redraw the comet with the new position. So this is the workflow that we are going to follow. Now let's open VS Code in order to see this second component that will allow us to do this. Here is the components that I have created for this section. You can see that we have the comet and we have this message. Whenever I press on Enter, you can see that the comet is moving. So let's see how to achieve this. First of all, again, we have the canvas, and this div basically contains this message, so that's not important. Let's scroll down a little bit so that we can see the mounted lifecycle hook. So we set up the canvas, we have seen this. We draw the meteor, and we add the event listener. If I look at the handle key press method, you can see that it is simple. We just check which key we pressed. If that's the Enter key, we are going to call the step animation function. Okay, so let's collapse this. And inside step animation, we will use the step size in both directions to basically update the position of the meteor. After that's done, we call the draw meteor method. Okay, so let's collapse the setup canvas again, and let's go to the data section. You can see that we have these same things, but here I have added the initial position. So this here we have 150 by 150, and the step size is 10 by 10. So basically this one will move the comet in a 45-degree angle, but if you want, you can change these values to control the angle. Okay, so this is what I have added inside the meteor object. Now let's go down to the draw meteor method, because we have made a little bit some changes. So you can see that here we no longer have the angle, but we are going to calculate it from the step size X and step size Y. So inside the draw meteor method, again, we start by clearing the canvas. We multiply the scale by the length and the width. We get the head X and head Y, and this time I am getting it directly from the meteor because this is where I want to spawn the meteor. And here is how we calculate the angle. So we calculate it like this. So we use the A10 method. Basically, we will use the step size Y and step size X in order to get the angle. Once the angle is calculated, the rest is the same. So what we have here is similar to what I have showed you in the previous component. Now, in order to calculate the tail point, we use headx and we subtract the length so that we get this point. Here we set up the global alpha to be the initial opacity. So here the opacity of the whole object is equal to 1. But if I change this to 0, let's say to 0.1, you can see that the whole object has a low opacity. So we want it to be equal to 1. And why I'm doing this? Because later in the final animation, usually meteors, they fade very quickly. So we want the meteor to appear with an opacity, let's say of 0.5. We will randomize that value, let's say from 0.5 to 1, and then we want it to quickly drop to 0 so that we simulate the case where the meteor has burned completely. Awesome. So this is why we are setting the global alpha. And here again, so we have the gradient, we calculate the base point for the base of the triangle, we draw the triangle, and we draw the head of the meteor. So yeah, this is exactly the same thing that we had before. The only thing that changed is how we calculate the angle. And as you can see now, so this is the initial position of the meteor. We start at 150 by 150. But now, since we added this event listener, the handle key press event will keep calling the step animation function each time we press on enter. So let's press it, and as you can see, the meteor moved, and it appeared very quickly because we cleared the canvas and we have redrawn the meteor, and it gives you that animation, which is cool. And if we this is what we are going to do in the next step. We are going to let JavaScript move the meteor automatically so that the movement becomes smoother. Here the step size is big, but if we want, we could have let's say a low value for the step size so that we get a smooth animation. So yeah, this is how it works, and this is why I have started with the comet designer, so that you can just copy that code and paste it inside the draw meteor, and you'll have your own design here that can be animated. Awesome. So now we will take all this knowledge and we will create the final result. Finally, we can take all these things that we have learned in the previous sections in order to create the meteor shower effects. Let's see how to do this. To simulate a meteor shower, we will spawn multiple comets. Here is how it looks like. Generally, comets appear from one source, and that source is called radiant. You can see that here I have tried to color it in yellow, and you can see that the comets come directly from this region. We are going to do the same thing in our effects. And here's the code corresponding to this. So we have the spawn meteor method. We have seen that before we were spawning them directly from the center, but now we are going to constrain that. So we are going to have this spawn zone width scale, and it could be a value between 0 and 1. 1 will be spawned, the radiant will be spanning the whole width. If we set spawn zone width to 50%, for example, then the radiant will be half the size of the width, etc. And after that, we are going to shift or center this radiant in the middle, because here by default it will be here if we get 20%, but we want to push it to be centered in the viewport. And this is how we do this. So we take the full width, we subtract the width of the radiant, and we divide by 2. This will give us that offset, and that will allow us to basically center the radiant. Also, I want to place the radiant outside the canvas. So here is the canvas. In the mounted lifecycle hook, I am going to create a radiant point. So the X will be the center divided by 2. So that will put the X coordinate here in the middle of the screen. But position Y will be a negative value. So I would like to place the radiant outside the canvas. And this is what I have showed you in the beginning of this video. And we can control this value so that we can come closer to the canvas if we want. And this will affect the angle at which the comets appear. So here are the boundaries of the radiant. And here, inside this spawn meteor method, we are going to pick a random point between these two boundaries. So here you can see that start Y will be always here at the top, but X can be anywhere in this interval. Let's say that X is here. So now we are going to calculate the angle in a different way, because now we want the angle, or we want the direction of the comet to be coming from the radiant point, and it should pass through the point. And this is how we do this. So now we don't have just one y value, but we have the y value for the point, and we have the y value for the radiant. Same thing for x. And this angle is here. So this is the only change that we need to make in order to have the that illusion of the comets coming from the radiant. So after spawning the meteor, we are going to store them in a list, because we will have many comets spawned maybe at the same time, or maybe if we have one comet spawned before the other one, the next one will spawn while the previous one is still alive. So we want to animate all of them at once. This is why this time we will have a list of meteors instead of just one. And each meteor has the following parameters. So we have position x, position y, the step, length, line width, opacity. Look at here step, what we are doing. We are multiplying that by the speed, because we also want some meteors to come very rapidly and some maybe not so rapidly. And we multiply x by cosine, and for the y we multiply that by sine of the angle. And this will basically help us move the comet at the same direction. Awesome. And finally, we are going to loop over the meteors and move them one by one. And here we have this request animation frame, which will allow us to call the draw meteors method each frame. So this is why I said that we will let JavaScript move the meteors for us, because instead of just hitting enter, we can run this function in each frame. So let's say that your browser runs at 60 frames per second. So this method will be called 60 times per second, and this will give us a smooth animation. Okay, enough talking. Now let's go to VS Code in order to see these changes that we have made, and also to play with the animation. Okay, here is the components that I have created for this section. Let me collapse this control panel because we don't have a lot of space. And as you can see, we have the comets coming from that radiant region. As you can see, sometimes we get multiple comets at the same time, because I have implemented a bursts functionality that will allow us to spawn, let's say, 2 or 3 meteors at the same time. And okay, so let's see what we have. So now we have a lot of constants, because we would like to control the speed, and we want this to be random. For example, we want the speed to be either 6 or 13 or any value in between. We also want to vary the length, the width, etc. So all those values that were inside the meteor object, we want to be able to control them. Okay, we have the same things, width, height, and now we will store the meteors inside this list. And we have the radiant points. Here we have the animation frame ID, and this is what will be used in order to move the comets automatically. Awesome. So inside the spawn meteors method, we start by defining that spawn region. You can see that now the spawn zone, let's see, so I think I can change it. Yes, so you can see that here I took 20%, but look what will happen if I increase this to 1. You can see that some comets now are going very to the right, because that spawn region is very big. But if I decrease it to, let's say, 0.01, now they will all come from the same region, and they will come vertically, because that spawn region is very narrow. Awesome, so that's working. And here, with this spawn zone offset, we will just center it. If we don't do this, then the comets will not be centered. So in fact, let's just remove it, and let's see what will happen. Okay, now let's save. And as you can see now, the comets, the spawn area is not centered. It is here, and the radiant is in the middle, so that's why they are going in this direction. Okay, so now let's undo the changes, and let's make sure that they appear in the right direction, and they seem to be. So now the x should vary, but the y should always be here, and here the angle. So I have changed the name to be trajectory angle just to be specific, and here is how we calculate that. And after that, the speed, length, width, opacity, those are going to be random. And the range, for all of those, we have the minimum and maximum values. Finally, we are going to add that meteor to the list so that we can animate them later inside the draw meteors function. Okay, so we are done with the spawn meteor method. Now let's look inside the draw meteors function. So here we have a loop. First, we need to clear the canvas so that we remove anything that we drew before in the previous step. And here we loop over the meteors. So we take the meteor, we have everything. So we have the position, we have the angle. Yeah, we got everything. We get the gradient so that we can draw the triangle and the solid head. And finally, we want to also, because sometimes if some meteors are very fast, they might go out of the wind, they might go out of the canvas, or sometimes the opacity might reach 0 or a negative value. So for those meteors, we want to remove them from the meteors list. This will simulate the case where meteors burn completely and they no longer exist. So this is the loop. And at the end, we have this animation frame ID, which, as I said, it will, so here we have this request animation frame, and it will call the draw meteors method each frame. So, and this depends on the frame rate at which your browser runs. So handle resize, we have seen this. Setup canvas, we have seen this also. Here we have this schedule next meteor, because we also have these two values, pause minimum milliseconds and pause maximum milliseconds. We don't want to spawn meteors very quickly, so we want to control that. And we use these two sliders to do that. You can see that if I set this to a higher value, you can see that I will not be getting a lot of meteors. So I have to wait a lot in order to get a meteor. But if I decrease this to 100 milliseconds, which is the lowest value that I have set, I can see now I get a lot of comets. So let's keep that to, let's say, 4 seconds and 6 seconds respectively. And let's go down. So when I enter this application, so I set up the canvas, I start drawing the meteors, but I also have this schedule next meteor. And this method will be responsible to spawn meteors regularly. And we have, this is how I do it. So I get a random value. If it is smaller than 50%, I will use the pause minimum milliseconds value. If it is greater, so I will use the maximum value. Okay, and here, basically, let's see, if the random value is smaller than burst chance, I will spawn multiple meteors. And in order to control that, I have two sliders. So here, let's set that to 5, and let's see what will happen. And also, let's set the burst chance to a higher value. And as you can see, now we get a burst of meteors. So instead of spawning only one meteor, we have this burst chance probability that we will use in order to spawn 5. It depends. So we will spawn burst minimum count meteors. And here, because both of them are set to 5, I keep getting 5 meteors each time the schedule next meteor gets executed. Okay, and here we use set timeout, and we provide those values so that it runs periodically. Okay, so this is how we spawn meteors without us pressing enter or doing anything. Awesome, so that's how it works. And this control panel is a whole component in Vue that will allow us to change those values. But that's not important. We want to look at the logic of creating this effects. So now let me remove the VS Code and let's look at this. Let's have some fun. So let's set this to 100 milliseconds and let's see what will happen. And let's decrease the bursts because I don't want it to be that high. Also, let's change the radiance position because I would like to decrease the angle. Let's increase the speed of some comets. Let's also decrease the minimum speed. Okay, and finally, I guess let's also increase this so that meteors die very quickly. So this is the factor that will decrease the opacity. And yeah, let's also decrease this. We don't want to have a lot of bursts. Yeah, so that's it. And you get something that looks like this, which in my opinion looks awesome. But I mean, in my website, I will be using this on my personal website. I will try to make them rare. So I will probably raise the interval to a higher value because in real life, if you go into a dark area, you don't see meteors very frequently. So they are very rare. And when you see them, that gives you a that's something very makes you happy, and it is very rewarding when you see something random like that. So yeah, I really like to see one comet like this, and it's an awesome effect. I hope you like it. And yeah, that's all I had to share in this video. In the next one, I will do something similar, but instead I will show how to add stars to the background and how to animate them, give them different colors, add diffraction spikes, etc. I think that one will also be an interesting video, and I'm really excited to work on it. Okay, so that's it for this video. I hope you enjoyed it. See you next time.